Dear civil engineers, welcome back to School of Civil Engineering. In this lecture, I am just going to show you that how we will design a mat foundation using CSI SAFE 2020. Okay, so if you are new, just go to your playlist given in description and first comment to watch your previous lecture about that software. So to design a mat foundation, first of all, from here we will use that option new model, or from here we will use the option new model. So I'll click here new model. After that, from here you can select any option. From here I will use that option. Use built-in setting with display units. I will use US customary. Then region, I'm going to use United States. Then the steel sectors not necessary for mat foundation, and steel design code also not necessary, but we'll go for concrete design code. So which code you want to select, I mean as per which code you want to design your mat foundation, you have to select from here. So I'm just going to use ACI 31819 code. Okay, so I'll just click here. Okay, so after that they have an option here, the base mat. Okay, but I'll not use that option. I'll directly use the grid only option here, the grid only option. And I will also not consider that value. Okay, I'll not consider that value. I'll just directly go for grid only option, and after that I will modify that value, and I'll go click OK. So before modifying our grid system, and before defining our slab system, we just have to define many things. So I'll just go here, define. First of all, we will define materials property. So to define materials property, just see here the default 4000 psi concrete properties are already defined, and here 60 grade reinforced concrete are also defined. This is as per ASTM A615 code, I mean the conditions. So if you need to add, then by clicking here you can add from here. So I'm not going to add, I'll just use that two option that are already in default. So after that I'll just click OK. And if you need to modify that, and if you need to know how to define that data, just go to a previous lecture and also learn about that. So I'll click OK. Then again I'll go define, and I'll go section properties. So from section properties I'll go here slab section. So from slab section, this is the most important thing, slab section, I'll delete that on. And they have a slab section, just I'll go here for add new properties. I will now add our mat properties, mat slab. So I'll click here, I'll just give here mat. First of all, I'll consider a 20-inch mat. Okay, mat, and I'll consider that will be 20 inch. And from here you have to select the slab material. So I'm just going to use 4000 psi concrete, and after that here modeling types, the shell thin or thick or membrane. So I'll use shell thin. And here modifier, so I'll not use any modifier for our mat. And from here the property data, the type, which types of slab we are going to use. From here mat. Okay, and from here what will be thickness, 20. Then click OK. So I'll delete that one. So here you can see that we have defined 20-inch mat. If I double click again here, 20-inch mat. Now I'll go for, after defining our mat, what do we have to define? Our column capital or column stiff. So I'll just go here for add new properties, column stiff. The slab materials properties, that will be same, and everything will be same. Just from here I will use stiff. Then the thickness, what will be the thickness actually? I'll consider just one thing, remember that the thickness of our mat and thickness of our stiff will be same. So I'll consider 20. Now I'll click OK. Then OK. So after that I'll go here for define, and I'll go for spring properties. So what is the spring properties actually? This is this is nothing but our soil properties, I mean bearing capacity of soil. But how we get our soil properties after soil testing process? So we get like TSF, PSF, like that. But here we have to provide data like the spring properties, area spring. So what we have to provide? Our area spring. Just remember that here for spring, the point spring means we'll assign that option for point spring for pile cap design. Okay, and for line spring, so if you want to design a wall foundation or anything, then you have to use line spring. And also if you go for a mat or the rectangular foundation or anything where you need the bearing capacity, direct bearing capacity, actually for shallow foundation you can use that. So here the area spring will use that option, area spring. Now I'm going to click here area spring, and just see here to define our area spring, I'll just click here add new properties. Now I'll just give here BC, that means bearing capacity. You can write anything here, BC. And we need one thing, soil subgrade modulus. Okay, subgrade modulus. So what is the subgrade modulus? This is nothing but our bearing capacity divided by bearing capacity, the ratio of bearing capacity and settlements. Okay, so I'll just go here. Here I've created a simple Excel file, and also that the Excel files download link are given in description in our free section. So from here, just three value you have to provide. What is the allowable bearing pressure, what is the factor of safety, and what is the allowable settlement. So I'm just going to provide here, just I'm taking a random value like what will be our allowable bearing pressure. So I'm just going to consider 2 TSF. And after that, what is the factor of safety? I'm going to consider 3. And allowable settlement in the foundation. So allowable settlement as per our code, that is 50, but for your code, I mean as per your code, you have to provide here the allowable settlement. And now see here, this is our value regarding key per inch cube. Here our value are key per inch square, that means key per inch cube. So for that value, okay, so for that value we have to I mean we need that value. I'll just copy from here, copy, and I'll paste it here as a value. And now I'll copy it and I'll paste it here, paste. Okay, and from here the linear option, non-linear case only. So here we'll go for compression only. Clear? After that I'll click OK, and we'll go for OK. So we have successfully defined our bearing capacity also. And after that we'll just go for our load pattern. So already 2 load patterns are available here, dead load and live load. So for dead load and for live load, we'll design, I mean only for our dead load and only for our live load, we are just going to design our mat foundation. And if you need to add any load like earthquake load or wind load, then you have to define that load from here. So just suppose if you need to define earthquake load or seismic load, then just define here W EX, okay, or EX for a dead load. Just see here the seismic option and click add new load. Just see here available. In that way you can also add your wind load. So I'm just going to delete that because I'm going to design our foundation only for I'm going to design our mat foundation only for dead load and live load. I'll just click here OK. So we have defined everything actually. Now we'll go for our and now we'll go for editing our grid system. So I'll right click, then add or modify. Then from here I'll just click here modify or show grid system, and here I'll change that. So now actually as you have to change that data as per your grid system, I mean as per your plan. So if you just see here, I'll consider we have 6 column in X direction and 8 column in Y direction. I'll consider that. Okay, so for that here in X direction 1 2 3 4 grid or 4 line are available. So I'll consider 6, so I'll add again and add again. So here 1 2 3 4 5 6, and in y direction I'll consider, okay, 7 grid enough. So 1 2, so here 1 2 3 4 5 6, and here another 7. Now I'll change, and they have two options: display grid data as ordinates and display grid data as spacing. So I will change that data as a spacing. So from A to B, what is the difference between A to B? You have to define that data. So I'm considering 15. I'm just taking random data. You have to provide that data as per your floor plan. So another one is, okay, 19. Then another one is 17. I'm just taking a random data, then 12, and then 16, like that. And again from that side, I'm just going for that value, 12, then 16, then 18, then 15, then 17, okay, and then suppose 13. So every data we need, we have already defined. Now I'll go for okay and refresh, and okay, just see, we have defined our data, and here we're seeing the distance, right? Now we'll take some point, I mean, now we'll draw our mat. So before drawing our mat, here I'll provide our column, here another column, here another column. Okay, so in this way I will define my column. But to do that, okay, so to do that I have to do something like I need some spacing. I mean, I need a point a certain distance away from that point. Okay, so I will do it, draw, then from here we'll just they have option, okay, they have option, so sorry, here draw joint object, click, and here I'll consider in y direction that will be 2 feet, okay, 2 feet in y direction, and x direction minus 2 feet, sorry, 2 means 24 inch, and here 24 inch, and from here just click, and actually it's not visible. When I'll go for when I'll refresh it, then it will be visible. And here also in opposite x I need another point here. Okay, just if I go here, suppose for plan view, just see here 2 points are available, here 1 and here 1. Clear? Now here also I need a point, so I'll just go here, draw joint object, and from here in x direction that will be 24 inch, and minus y direction 24 inch, and here 1 point, and here I'll take another point, so that will be 24 and 20, I mean plus 24 plus 24. So here I'll take a point, I'll just draw a I mean a different types slabs, so here 1 and here 1. See, if I just go here plan view, just see the available point, I mean our record points are available here. Now I'll draw our slab or mat. Now I'll use that option, draw all our floor. From here I'll select our mat, okay, from here I'll select mat, and now I'll click that point, and again that point, again that point, and here after that I'll click here and here, and I'll click, okay, just see we have, I'll skip. Now see our mat are available, we have complete our mat. Now when our mat is okay, now we'll go for our column strip or column position. So for that I will use that option, draw quick area around a point, and for that I will change that value for column strip. So what will be the size of our column strip? So I will consider our all column will be 12 into 12 12 into 12, so that we can assign, okay, consider our the outside column will be 12 inch into 12 inch, okay, so here that column will be 12 inch into 12 inch, Okay, click here for 12 inch. So here we're applying that value. Done. We are drawing our outside column. Done. Now actually if we want, we can use that option, but this is okay. Then our another column will consider in x direction, that will be 15, and in y direction that will be 18. So here I'll draw all of our columns. Sorry. Okay, I'm done. So we have created all of our columns here, right? Just see, we have created all of our column strip and everything we have done actually. So if we go for a 3D view, just see here all of our strips are available. We have done that perfectly. And also if we go for extrude view, just see in extrude view everything is okay. Okay, now I'll just escape and I'll go for plan, and from here okay, now we'll apply load on it. So to apply load on it, actually what we have to do actually to apply load on it, I just need a point here, right? So to draw point, I'll just skip that, and from here draw joint object, and at 0, 0 point I'll draw point, because without drawing point we'll not be able to define our column load. Okay, so they have a issue. So I'll take point here, and after that I'll do something. Okay, so I'll skip, and I'll just check that are all. So if I just click here, just see if joint have selected, that means our joint have created. Now I'll check one thing. Just I'll click here, draw, sorry, I'll click select, from here select, then object type, and then slab object, and from here column strip, and then select. So just see everywhere I mean we have selected, so they have an issue, or that column have column position have changed, and also they have no columns. So skip, and now I'll select that on, and I'll draw again here column strip 18 into 12, and I'll just draw here. Okay, now it's done. Now if we go for column strip, so here it's available, and sorry, here we also need one, then here. So everything is okay. Now again if I go for it, just see everywhere the column strip are being selected. Now I'll close that. Okay, and here we'll consider that our dead load and live load I mean, we'll consider our dead load and live load. So for our outside column, our dead load will be different and live load will be different, because we have to assign that value separately, because our that column size and that column size are not same. So when your column size are different, then you have to define your data differently. So I'll select that point, okay, carefully. I'll select every point whose column size and load are also same. So I'll consider our every load are same. So here one, carefully have to select that on here, sorry, not that one, that point, here. Okay, done. So we have selected. Now I'll go assign, then from here joint load, then force, and I will apply load here. So here I will apply minus. Suppose what will be our gravity load? I'm just considering a random load, suppose 50 keep or 100 keep. Then what will be moment? I'm considering on moment will be 25, and our x y moment will be 12, like that. And the most important thing is, what is the dimension? It actually, this is the same dimension you have provide for your column capital when you have created your column capital. So 12 into 12, right? Then click apply. Just we have done here. Just see here we have provided our load perfectly. Okay, so same way you have to provide the load in middle position. So I'm not going to assign load on middle position. I'm just showing you that how we can use that software perfectly. So just you have to select that middle point same way, and then you have to assign your load. Now I'll go for analysis. I'll click here, and from here I'll select save mat footing, and save. Okay, just okay, and wait for some time. It's being analyzed. Okay, I'll just click okay. Okay, now see here our the finite element analysis of our structure. So in that side, okay, and if we just see here, this is actually this is the displacement. This is the displacement of our structure. Okay, so they have some issue with our model actually, as this is a as this is a mat foundation. So just see here, this is showing our displacement actually. Now if I just go here for our another check, so here I'll go here display, then I'll go show for punching shear value. Just see the point we have selected, or the thickness we have selected, that are also same, right? Everything are same. And if I just go here, oh sorry, I'm extremely sorry, I just have to uncheck. Okay, unlock. I'll select our mat. We did not provide our soil property actually. So here I have to go here assign, then we'll go for our here the frame, sorry, shell, assign shell, and from here we'll go for area spring, and that is BC, and apply, then okay. Just see we have applied our bearing capacity, bearing capacity value, soil subgrade modulus value, and now we'll go for analysis and see what happened actually. Okay, now it's giving a better diagram actually. In mid side, at mid side they have little displacement, and the outside, I mean here they have a much more displacement. Just see here the maximum displacement now 0.35. okay, so what is our allowable displacement? 1.96 inch, but it's showing us only 0.35. so for combination actually, I'll just go here, show deform shape for combo. So for combo S1 they apply. Now see the maximum displacement here showing 0.5 actually for combo 1, and for combo 2 actually you can define the combo you need. So this 0.42, this also. So I'll close that, and I'll go for our soil pressure here. So from soil pressure everything is okay, and I'll take our soil pressure for combo 1, and okay, done, show values, then apply. Just see what is our allowable soil pressure, that is 440. That 2 TSF means 440 weight pounds per square feet, but here our maximum value are showing here 3359 lb per square feet. That means our settlement are also okay, our punching shear are also okay. So in this way you have to analyze your model. So when it's done, now we'll go for design. So how will go for design? To design, I'll click here, display, then show slab design, and from here I'll just move it that side. So from here I'll just go for finite element based design method, impose minimum load, and for 1 I'll just click apply. Just see here it's showing us the reinforcement requirement for our mat, and for direction or top direction apply. So here they have no requirement of reinforcement here, just need here little bit, and here also here little bit, and also for direction to apply here how much reinforcement we need actually here, and also here just see how much reinforcement we need actually. Now if we go for that option, typical uniform reinforcing, so if we consider, if we use number 5 bar and with a 8-inch and 8-inch spacing for top and bottom, now see what happened, then apply. Just see here we need a little bit reinforcement, and with that spacing with number 5 bar our structure are okay, and here for top this is also okay, for bottom this is also okay, and for top again direction on also okay. See if we increase the top reinforcement in 12 inch, just see here also we need reinforcement. So if we go for 10 inch, then here we need little bit, then if we go for 8 inch, then it's okay. So this is the way to design our mat foundation actually. So for details understanding, or for details things, just you have to go our previous lecture already we have created, that link are given in description. So thank you very much. Still stay connected till next video, and if you think that lecture was helpful for you, please join as a member in our channel to support us, and also if you can give us super thanks from YouTube. So thank you very much, and don't forget to subscribe to our channel, and also like our video, and obviously share this video with your friends. So thank you very much. Still stay connected till next video.